Alright, so this video we're going to look at the trigonometric functions. Alright, so let's suppose that we have an angle in standard position. Okay, so you should remember what standard position is. That's what we went over that in previous videos in this playlist. Remember, it's when the initial side is along the positive x-axis, and then we rotate it, and the vertex is at the origin, at the point 0, 0. So if xy is any point other than the origin on the terminal side of an angle alpha, all right, so here's our angle alpha, and here's the terminal side, and we have our point here, xy, in standard position. We just talked about that. And r, which is this distance from the origin to the point here, that's the distance from here to here, is the square root of x squared plus y squared. Then we have all this stuff right here. Now, this is a right angle, okay? And so if this is our point xy, then the distance from the origin to this point right here, that's x, and then the distance from here to here, that's y. Now, to get r, all they're doing is they're saying r squared is equal to x squared plus y squared. And then if we take the square root, we get r is equal to the square root of x squared plus y squared. And that's where r comes from. All right, so we've got this. We've got sine alpha. Here's our angle alpha. So sine alpha is y over r. Cosine alpha is x over r. And tangent alpha is y over x. Just got to remember that. Okay? Now, it does have cosecant, secant, and cotangent also. You don't need to memorize those. Okay? Because in this, and I'll come back up here in just a second, but we've got these reciprocal identities. This is just saying that cosecant and sine are reciprocals of each other, secant and cosine are reciprocals of each other, and cotangent and tangent are reciprocals of each other. So remember, reciprocals, that's when you flip the fraction. So that's all this is. If you can just remember, and you'll need to remember this, that sine and cosecant are reciprocals. See, y over r, I just take the reciprocal, r over y. Cosine and secant are reciprocals. Cosine is x over r, the reciprocal, r over x. And same thing with tangent and cotangent. So all you really need to do is remember these three, and then you know sine, cosecant, cosine, secant, tangent, and cotangent are reciprocals. So if you know these first three here, you can get the second three. Okay? All right, so we went over the reciprocal identities. So let's look at this example here. They want us to find the values of the 6 trigonometric functions of the angle alpha in standard position whose terminal side passes through 2, negative 1. All right, so what I like to do, I like to just maybe draw this out. So we've got our point 2, negative 1. Okay. Now notice when I drew that point, I didn't put 2 marks here and go over 2 and down 1. Okay. This right here is just kind of estimating where that point will be. Okay, that's all it is. It's just estimating where the point will be. The main thing is what quadrant is it in. Okay, all right. So now, if we draw our line up here, we get our x is 2, our y is negative 1, and so we need to know what r is. Well, remember, r is the square root of x squared plus y squared. And so we get r is the square root of 5. and so this is the square root of 5. All right, so we've found everything. So now let's find the let's find all 6 trig functions. Okay. All right, so we get sine alpha. Well, what is sine alpha? It's y over r, right? Y over r. Well, you can do this. You can write this is equal to y, this is equal to x, and this is equal to r. And so we get y over r. That's -1 over square root of 5. Now, you don't want to leave your answer like this. Remember, you can't have a radical in the denominator. So we need to rationalize the denominator. So I need to multiply numerator and denominator by square root of 5 over square root of 5. So that's negative square root of 5 over 5. So there's sine alpha. Okay. And then I need cosine alpha. All right. So cosine alpha is x over r. So that's going to be 2 over square root of 5. And then I will need to rationalize the denominator. Okay. Now, we're in trig now. So this step here that I did where I wrote out multiplying by square root of 5 over square root of 5, I'm not going to write that anymore. You should be at the point where you can rationalize this denominator in your head. So if I'm multiplying numerator and denominator by square root of 5, that's going to be 2 square roots of 5 over 5. And then I get tangent alpha. That's what? That's y over x. So y over x, that's -1 over 2. All right, so I've found sine, cosine, and tangent. Now I need to find cosecant. Okay, so cosecant is the reciprocal of sine. Now, be smart about this, okay? Be smart. Now, let me show you something that a lot of students would do, but you don't want to do this. I mean, you can, but you're putting more work on yourself. So if I take this square root of negative square root of 5 over 5, and I flip that, you see what happens? Now I've got to rationalize the denominator. And if I rationalize the denominator, that's going to give me -5 square root of 5 over 5. And the 5's cancel out, and I'm just left with negative square root of 5. Okay? You can do that, that's fine, but you put a whole bunch of work on yourself that you don't need to. Now, remember, this is the same thing as this. Okay? Forget about this. That right there is just rationalizing the denominator. Okay? Sine alpha is equal to this right here. And then after we rationalize denominator, we get this. This and this are the same thing. If you punched them in your calculator, you would get the same answer. So what would make more sense, instead of taking the reciprocal of this one, would be to take the reciprocal of this one, which is what? Negative square root of 5. See, now you don't have to rationalize the denominator. And that's what I mean when I say be smart about it. Okay? Now, what about this one? Secant alpha. Okay? I can take the reciprocal of this 2 square root of 5 over 5, or I can take the reciprocal of 2 over square root of 5. Well, I'm going to take the reciprocal of 2 over square root of 5, which that would be square root of 5 over 2. And then cotangent alpha, well, the reciprocal of -1/2 is -2. All right, and there's your 6 trig functions. All right, let's see what we've got here. Okay, find the exact values. Okay, find the exact values. Now, for this one, I'm gonna work this out. Okay, I'm gonna work this out, and I'm gonna do it the long way. Okay, but and I'm doing it the long way just to show you how it works out, but you're not going to work them like this, as you go through the trig course. Sine of 90, sine of 180, sine of 270, sine of 360, sine of 0. Those, you need to memorize those, okay? Something that's very important in trig is for you to remember the sine, cosine, and tangent of 0 degrees, 30, 45, 60 degrees, 90, 180, 270, and 360. Memorize those. If you memorize those, your life's going to be much easier in trig. If you don't memorize those, your life's going to be more difficult, and you may have to repeat the class. Okay? You may be taking trig a second time. So just memorize them. But now let's just go ahead and look at this. All right. So if we have 90 degrees, here's our initial side, right? And 90 degrees is right here. And so if I put a point there, that would be the point 0, 1. Okay? Now, what you might be thinking, where in the world did you get 0, 1 for your point? Why are you using 0, 1? Well, if I wanted to, I could have used the point 0, 5, and I would get the same answers. Okay? I could use the point 0, 1 million if I wanted to, and I would get the same answers. I can use any point on the y-axis that's above the x-axis. Okay? Any point from here, well, of course I can't use 0, 0, but any point above 0, 0 that's on the y-axis. All right? So, when we look at this, we see that x is equal to 0, y is equal to 1, and r is the square root of 0 squared plus 1 squared, which is 1. Okay? So we know what? We know x, y, and r. So I've got sine of 90 degrees is equal to what? Y over r, which is what? Y is 1, r is 1, and so there's your answer, 1. All right, so what about tangent of 180? All right, well, let's draw this. If this is my initial side here along the positive x-axis, 180 would be over here. See, it would be rotating there to 180. Now, what would this point be? Well, if I'm moving to the left, I can make this point -1, 0. And like I said, you can pick any point on this line that's to the left of the y-axis. Okay? So I could pick -10 million, 0 if I wanted to. I could pick -√3, 0 if I wanted to. Just pick the 1 or the -1. That's the easiest. All right? So I've got x is equal to -1, y is equal to 0, and r is the square root of -1 squared plus 0 squared, which is 1. Okay? Now, tangent of 180, well, tangent is what? Y over x. And so y is 0, x is -1, and so that would give me 0. All right. All right, let's look at this. Cosecant of -5 pi over 2. All right. Now, we don't do good with angles that are not between 0 and 2 pi. Okay. Typically, when we work with angles, we want our angle measure to be between 0 and 2 pi. Well, can we do that? Yes, because you've learned that earlier in your trig course. Okay, if you were paying attention in class, you've learned this already, that we can take negative 5 pi over 2 and we can add 2 pi, right? So if I add 2 pi, that is going to actually give me what? Negative pi over 2, all right? Because if I put this over 1, get a common denominator of 2, that would be 4 pi over 2, so that would be negative pi over 2. So I would have to take the negative pi over 2 and add 2 pi again, and that would leave me with 3 pi over 2, okay? Now, how can I do that? What have I done? I've used coterminal angles, okay? Remember that from earlier in the course? If you add 2 pi or 360 to an angle, they're coterminal angles. They have the same terminal side, okay? So here, do we know 3 pi over 2? Yeah, 3 pi over 2, that's 270 degrees. That would be right here, all right? If we have our angle in standard position, okay? Now, 5 pi over 2 would rotate differently, right? It would rotate a little bit different. It would rotate back, let's see, like this, okay? But the thing that we're concerned about, the thing we're looking at, is this right here, this line that it's on. Okay, so we could make this the point 0, negative 1. So here, x is 0, y is negative 1, r is the square root of 0 squared plus negative 1 squared, which equals 1. So there's r. Okay, so I get, let's see, what are we doing? Cosecant. So cosecant of negative 5 pi over 2 is equal to, all right, so let's be careful here. Cosecant, what do we know? Well, we know sine is y over r, so cosecant is r over y. They're reciprocals of each other. Okay, remember, sine alpha is y over r, so we know cosecant is the reciprocal of that, which is r over y. And so that's going to be 1 over negative 1, which is negative 1. And there's your answer. All right. All right, so let's do cotangent of 0. So cotangent 0. So if this is my initial side, well, rotating 0 degrees, we'll call that 0 degrees. I didn't put a degree symbol, but it doesn't matter if it's in degrees or radians. Well, let's just say it's in radians. That's fine. Doesn't matter. It's still we can put our point right here. So this would be the point 1, 0. Okay, and once again, you could do 110, 0, or 3.5, 0. It doesn't matter. So I get x is equal to 1, y is equal to 0, and r is the square root of 1 squared plus 0 squared, which is 1. And we know cotangent of, 0. Okay, so cotangent, well, we know tangent alpha is what? Y over x. So cotangent is x over y. And so that is going to be 1 over 0, which that would be undefined. Okay. All right, so that's those. See, that's all it is. That's what you have to remember. Where is it? That's what you got to remember all of this for. You can work problems like that. Okay, so it doesn't matter where it is. You know, if you've got a point right here that's not on one of the axis, on one of the XY axis, If it's not there, then now you know how to work it. I did one that fell on each one. All right, so here we have 45, 45, 90 triangle. And I know, I think a lot of teachers like doing this, like showing this. But look, you don't really have to memorize these, this 45, 45, 90 triangle. I'm going to show you how to work the 45, 45, 90 triangle, but you're going to memorize these things later on, okay? But let's just go ahead and look at it. So here we have a 45, 45, 90 triangle. The two angles here are 45 degrees. You got a 90-degree angle here. This right here is a leg of the triangle. This is a leg of the triangle. And this right here, the side opposite the side opposite the right angle is called the hypotenuse. So if we label this 1, we label this 1, then look at that. This is R. That's just what? Square root of 1 squared plus 1 squared, which is the square root of 2. That's where that square root of 2 comes from. All right, so find the exact value of each function. Okay, find the exact value of each function. So we have the sine of 135 degrees. All right, so let's go ahead and draw this out. So 135 degrees, that is here. Okay, and that's in the second quadrant. We'll talk about the quadrants more later on. But if this is 135 degrees, then we know this angle here is 45 degrees, because from here all the way to here is 180. So 135 plus 45 more, that would make the 180. All right, and then we drop this down. That's a right angle. Well, if this is 45, well, we know this is 45. And we can label this 1, 1, and square root of 2. Okay? Now, when you look at this, okay, when you look at this, yeah, I labeled it 1, 1, and square root of 2, right? Well, actually, I'm doing what? I'm coming over -1, aren't I? You see that? Where x, see, because to get to this point right here, this would be what? This would be the point -1, 1, wouldn't it? I would have to come over to the left 1 and up 1. And so now I get the sine of 135. That's what? Y over R, which that is what? Well, what's y? That's 1 over R is square root of 2. And then I'll rationalize the denominator. So that would give me what? Multiply numerator and denominator by square root of 2. That would be square root of 2 over 2. Okay. All right, so what about 5 pi over 4? Let's look at that. 5 pi over 4. Well, we know this would be 0. This would be pi over 2. This would be pi. This would be 3 pi over 2. And this would be back to 2 pi. Okay, because remember, 0, 90 degrees, 180 degrees, 270, and then back to 360. So that's another thing in trig. You need to memorize this. You need to know this. When you see pi over 2, you automatically think 90 degrees. Or when you see 90 degrees, you automatically think pi over 2. You've got to know that. And then the other ones you've got to know that for is 30 degrees is pi over 6, 60 degrees is pi over 3, and 45 degrees is pi over 4. Okay? You've just got to know that. Okay? So if we do 5 pi over 4, that's going to be an angle measure right here. Okay? This would be 5 pi over 4. Okay. Yeah, that'll be 5 pi over 4. Now, let's look at this. If this is 5 pi over 4, I wonder what this angle is. Well, we can find out real quick. We can do 5 pi over 4 minus, so if I go 5 pi over 4, and then if I take off pi minus pi, that's going to give me pi over 4. So this is like 45 degrees. And then if I push that up, this is 45 degrees, and there's my 90-degree angle. And so I can label this 1, 1, square root of 2. Okay? But let's look at it again. Okay, let's look at this. This right here, this point here, I'm actually what? Going to the left 1, so that's negative 1. I'm going down 1, and so that would be the point negative 1, negative 1. And so I've got x, y, and r. And so remember, cosine is x over r, which, let's see, x is negative 1 over r, which is square root of 2. And then if I rationalize the denominator, multiply numerator and denominator by square root of 2, that's going to give me negative square root of 2 over 2. And there's my answer. Okay. All right, so what about this one? Tangent of negative 9 pi over 4. All right, so once again, let's do our coterminal angles and get it back to something we know. So if I do negative 9 pi over 4 plus 2 pi, well, that's, now remember, see 2 pi, if I get a common denominator of 4, because that's 2 pi over 1, if I get a common denominator of 4, then that changes to 8, so that's negative pi over 4. Okay, well, we're not between 0 and 2 pi right now, are we? No, but let's use some common sense here. I'm where? I'm at negative pi over 4. So if I have an angle in standard position, if my angle's negative, I just rotate clockwise, and I'm rotating clockwise this way. I know this angle here is pi over 4, which is 45 degrees. Okay, so there's my, that's the thing I'm trying to get here, is my 45, 45, 90 triangle. And there's my 90. And so I've got 1, 1, square root of 2. Well, that's positive 1, but I'm coming down, so that's negative. So this would be the point 1, negative 1. Okay. And so now I get this. Let me see something real quick. Yeah. Okay. So this would be what? I've got tangent, that's y over x. So let's see, y is negative 1, x is positive 1, and so that would give me negative 1 as an answer. All right, so, you know, like I said, you're not gonna be finding these exact values of these trig functions. You're not gonna be finding them like this as you get into the trig class. Okay, you're gonna know that the sine and cosine of 45 degrees is square root of 2 over 2. And then if you don't have 45, if you have something like this 135 degrees or this 5 pi over 4, you have something like that, well, you're going to use what we call reference angles. If you're not familiar with that, reference angles, that's in, I think it's the next section or the section after that. It's coming up in the next video or one of the next 2 videos. Let me see. Yeah, it's not the next video, but the one after that. It's called the fundamental identity and reference angles. All right, that would be the title of the video. You're going to use reference angles, and then the fact that you've memorized sine and cosine of 45 is square root of 2 over 2, tangent 45 is 1. Okay? But for right now, let's, we're working them like this. And to me, I think it's good practice for you to get them up, to be able to work them like this also. All right, so that was the 45, 45, 90 triangle. Now let's look at the 30, 60, 90. Now also, if you want to, you can search my channel for 45, 45, 90 triangle and 30, 60, 90 triangle. I have videos on just that, and it goes into more detail than what I'm doing here. So if you want to check those out, just search my channel for those. All right, so let's look at the 30, 60, 90 triangle. So we have a right triangle. We got our 90-degree angle, and one angle is 60 degrees, the other one's 30. And we can label this thing as the side opposite the 30-degree angle is 1, the side opposite the 60-degree angle is square root of 3, and then the hypotenuse is 2. Okay, and you can get this by using Pythagorean theorem, or the square root of 1 squared plus square root of 3 squared. All right, so let's look at this. Let's find the exact values. We got 3 of these to work, and then we've got some stuff with calculators, and that'll be it. Okay, so let's go through these, and it's going to be similar to what we did. So let's go ahead and do cosine of negative 60. So remember what I've talked about a lot is, okay, we like to work with angles between 0 and 360, or 0 and 2 pi. We like working with those. But this negative 60 degrees, well, here's my angle, and I'm just rotating negative 60, so that means this is 60 degrees. And then if I draw my triangle, this would be 30 degrees. See, all 3 angles add up to 180. 60 plus 30 is 90, plus 90 is 180. All right, so now let's just label the triangle. So remember, the side opposite 30 is 1, the side opposite 60 is square root of 3, and the hypotenuse is 2. All right. Now, if we look at this point here would be the point what? 1 negative square root of 3, right? It would be negative because we went to the right one on the x-axis, so that one's positive, but then we went down, so that's negative square root of 3. And we're looking for cosine. Cosine is what? X over r. So x is what? 1, and r is 2, and so we get 1/2 as our answer. All right. So now let's look at the next one. Sine of 7 pi over 6. Sine of 7 pi over 6. All right, so let's draw 7 pi over 6. So, you might want to label this 0 pi over 2 pi, 3 pi over 2, and 2 pi. All right. So, well, where do we draw that? Well, you could, if you wanted to, you could do 7 times 180 and then divide that by 6. Convert it from radians to degrees. That's 210 degrees. And so we know 210 degrees, that is in the 3rd quadrant. Okay? So this angle from here to here is 210. But we're concerned, what is this angle? What is that angle? Well, to find that, Well, we could take the 7 pi over 6, the 7 pi over 6, and subtract pi. And that would give us, let's see, what is that? Pi over 6. It gives us pi over 6. And so we know this is 30 degrees. Because pi over 6, remember, pi over 6 is the same thing as 30 degrees. If you take pi over 6 times 180 over pi, converting it to degrees, pi's cancel out, you're left with 30. Okay, but that's one of the ones you should know. Pi over 6 is 30 degrees. 30 degrees is pi over 6. So if I bring this up, I know this is 60 degrees, and that's my right angle. So the side opposite 30 is 1. The side opposite 60 is square root of 3. And my hypotenuse is 2. See, all I'm doing is labeling it like this triangle. See, the side opposite 30 is 1. The side opposite 60 is square root of 3. And the side opposite the hypotenuse is 2. And that's all I've done. See, here. Side opposite 60. Side opposite 30. And then the side opposite 90. See if I can erase this without erasing anything else. All right. Now, what's this point right here? Well, this would be the point what? Negative square root of 3, negative 1, right? Because I went to the left and I went down. So now let's look at sine. Sine is what? Y over R. So let's see, we've got Y, which is negative 1. So that's negative 1 over R, which is 2. So that's negative 1/2. Okay. See, this isn't that bad. All we're doing is trying to set it up to where we get a 30, 60, 90 triangle, or we get a 45, 45, 90 triangle. That's what we're trying to make. All right. All right, so let's look at this one. Negative 240 degrees. Well, let's use coterminal angles here. Okay, so I've got negative 240 plus 360, and that equals 120 degrees. Yeah, I punched it into my calculator. I don't want to take any chances on getting any of this wrong, because I'll hear it in the comments if I do. So we're here. Okay, so yes, we're doing negative 240, which that would come this way. That would be negative 240. But we know this is what? 120, because we did what? We did 360. See, if you draw this back, we did see, this is negative 240. So if we do 360 plus 240, we're left with this 120 here. And so what's important here is to get this angle here. Well, I know this is 0, 90, 180, and 270. So I know this angle here would be what? 180 minus 120, which is 60 degrees. So this is 60 degrees. I'll drop this down. So this is 30 degrees. So this is 1, square root of 3, and 2. Well, and this point here, that's going to be what? Negative 1, square root of 3. So we got the negative here because we went to the left. That square root of 3, it's positive. We went up, okay, on the y-axis. And so I need tangent. Let me get this out of the way. Okay, so tangent, that's y over x. So that's going to be, let's see, y, which is square root of 3, over x, which is negative 1, And so that's negative square root of 3. And so there's tangent of negative 240. All right. All right, so I hope so far all of this is making sense. Okay. Now, we've got this right here to plug into the calculator. But what I want to do is I want to write this down for you because it's so important that you get this. We'll get to the stuff in the calculator. I mean, that should be easy. The only ones that you might struggle with is the cosecant, secant, and cotangent, plugging that into your calculator. But I'll go over that. All right, so we've done all this. We've done the 45 45 90 triangle. We've done the 30 60 90 triangle, and like I said, you're not going to draw those. Okay, you're not going to really do it like that. But it's good practice, and basically what you're going to do is memorize these things. You're going to know them. Okay, so let me write down what you need to know. So sine 30 is 1/2. Sine 60 is square root of 3 over 2. And sine of 45 is square root of 2 over 2. And then we've got cosine 30 is square root of 3 over 2. Cosine 60 is 1/2. Cosine 45 is square root of 2 over 2. And then we've got tangent 30 is square root of 3 over 3. Tangent 60 is square root of 3. And tangent 45 is 1. Okay? You've just got to know them. You've got to know those. All right? And then the other ones that you need to know is the sine, cosine, and tangent of 0, 90, 180, and 270. You've got to know those also. Okay? But it's important that you know those, and it's really, really, really important that you know those. Okay? So, honestly, it's easy to remember. Okay? Do you need to memorize all these? Well, yeah, but this is, I think, the easiest way to do that. You know sine and cosine of 45. Most everybody knows that's square root of 2 over 2. And the tangent of 45 is 1. Pretty much all the students remember this. It's the ones up here that they get messed up. Okay? So when we're talking about 30 degrees and 60 degrees with sine and cosine, we'll get mixed up 1/2 or square root of 3 over 2. Which one is it? Okay, it's one of the two, right? Well, look, the only one that you've got to remember, just remember sine 30 is 1/2. Okay? Sine 30 is 1/2, then you know cosine 30 is the other one. You see what I'm talking about? So you know it's either 1/2 or square root of 3 over 2. So if you remember sine 30 is 1/2, then cosine 30 is the other one, square root of 3 over 2. And then when you go to sine 60, well, if sine 30 is 1/2, sine 60 has to be square root of 3 over 2. Cosine 60 is the other one. See that? And then tangent 30 and tangent 60, you got square root of 3 over 3 and square root of 3. Students mix that one up a lot also. The easiest way to remember it, I think, is you see the 30 degrees. Okay? See there, square root of 3 over 3 and square root of 3. Well, do you see how 30 has a 3? So it's the one with the most 3's in it. And so tangent 60 is the other one, square root of 3. If that helps, I don't know. Okay? That's, some students remember it like that. If you know another way to do it, perfect. Use that. Use what works. Use what's going to make you pass the class. All right. So, Let's look at this. Find each function value rounded to 4 decimal places. All right, so we got sine of 4.27. So punch that into your calculator. Okay, so here's where you can interact with the video. Now pause the video, punch all those in, see if you get the right answer. So sine of 4.27, that is, rounding to 4 decimal places, is negative 0.9037. This is a 3. I know it doesn't look like one, but that's a 3. And that is a decimal point on the 9. All right. Now, I don't know if you got that right or not. If you got that wrong and you punched it into your calculator, I bet you I know why. Remember, 4.27, do you see the degree symbol on it? No, that is in radians. So make sure your calculator is in radian mode. Okay. Now for this one, cosine of negative 39.46, that is 0.7721. Now, on the first problem, your calculator had to be in radian mode. Well, what did they do? Next problem, they want to make you work. Got to put your calculator in degree mode now because the angle's in degrees. All right. And then we got tangent of pi over 7. That is going to be 0.4816. Make sure your calculator is back in radian mode. So all you're going to do for this, you're going to hit sine and then type in 4.27, enter. Make sure your calculator's in radian. Make sure your calculator is in radian. Hit tangent and then type in pi divided by 7. Hit enter. Same thing here, just type that in, cosine, and then hit the little negative button. It's going to be the minus sign with the parentheses around it. And then type that number in, hit enter. Make sure your calculator is in degrees. Okay. I don't typically get on here and show how to use calculators. I don't even really show how to use the calculators in my classes because everybody's got a different one. All right. So let's look at this one, cosecant, secant, and cotangent. Now, this is the one where everybody, well, I don't know where the cosecant and secant button is, and a lot of times what students will do, they'll have a button that you got this button on your calculator, sine, and then you got one up here, inverse sine, and they'll go and hit that one. That's not cosecant. That's inverse sine. Okay. So what you've got to do, and I'm going to show you this on all of them, and I'll write the answers down and you should be able to get them. Well, remember, cosecant is the reciprocal of sine, so this is 1 over sine of 3.88. And that is equal to negative 1.4856. Okay, this is the key right here. You got to be able to do that. You got to know that. Just like this one, that's what? That's 1 over cosine of negative 9.24 degrees. Make sure for this first one and this third one here, your calculator's in radians, and this one, your calculator needs to be in degrees. And when you punch that into your calculator, you get 1.0131. Okay? So, and remember, when you do this, you got to do 1 divided by and then sine 3.88 and then hit enter. Okay? And then this one, this would be what? 1 over tangent of pi over 5. So you'll type in 1 divided by tangent pi divided by 5, close your parentheses, hit enter. And if you did it correctly, you will get 1.3764. There's the answer to that one, and that one. And look at that. That is the last ones. That's the last problems. So hopefully that helped. Just remember, it's really, really important in Trig that you get all this stuff, that you understand all this stuff at the first of the class. You've got to understand that. Okay? It's going to make it so much easier when you get towards the end, because when you get towards the end of Trig and you're doing all this other stuff, you're going to be using all this stuff you learned it first. All right. So hopefully this helped. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.